Chapter 1: Introduction and Basic Concepts. All right, everyone, let's sit together and imagine something simple first. Have you ever played with water in a bucket? You notice when you stir it, the water moves around, it splashes, and after a while it settles again. What you just saw, actually, is a real-life example of something called fluid mechanics. Fluid mechanics is like learning how liquids like water and gases like air behave, whether they're moving fast like in rivers or sitting still in a glass. When we talk about mechanics, we just mean the science of how things move or stay still. So fluid mechanics is how fluids behave when they are resting or moving. Let's think about a chocolate pudding. If you put it on your hand, it kind of sits there and holds its shape. That's because it behaves more like a solid. But when you pour water, it just flows out and spreads everywhere. That's because water is a fluid. Fluids can be either liquids or gases. So air is a fluid too. Imagine blowing on a balloon. You don't see the air, but it moves and fills the balloon, just like water fills a bottle. Now, when we push or pull on solids, like rubber, it can bend and then come back to its shape. But when you push water, it never comes back. It just keeps moving away from your hand. That's because fluids always keep flowing under force, no matter how small. And that's why when you shake a bottle, the water inside goes crazy, but a solid chocolate bar won't change much. Another thing, imagine holding your finger under a tap. The water doesn't fly off your finger. It slows down right where it touches you. That's called the no-slip condition. Fluids always stick to a surface, like glue, and slow down to zero speed right at the surface. Now, let's see how engineers, like me, use these ideas. Have you seen a car moving fast? The shape of the car helps it move faster through air, reducing something called drag. This is fluid mechanics, helping cars become smooth and efficient. It's also how planes fly, how water goes through pipes, and even how your air conditioner cools your room. In history, people learned to move water using aqueducts in old Rome or pipes in ancient Turkey. A smart man named Archimedes figured out why things float in water. Then others like Newton and Bernoulli learned more. And finally, smart folks today use computers to study fluids. We also learn how to describe flows using simple words, like, is it flowing inside a pipe or outside over a ball? Is it moving fast and wild like a river or smooth like honey? Is it changing with time or staying steady like a calm lake? Engineers have funny names for all this: laminar, turbulent, steady, unsteady, internal flow, external flow, and even sonic flow, like in fighter jets. One cool thing we do is break problems into systems. Sometimes we look at a whole amount of water, like in a bottle. That's a closed system. Sometimes we just care about water flowing through part of a pipe, which we call a control volume. It helps us understand and calculate easily. And finally, we use numbers to measure everything. You've heard meters, kilograms, seconds. These are SI units. And sometimes you hear pounds and feet. Those are English units. We have to be very careful with units, like how you wouldn't mix up kilometers with meters when running a race. So remember, fluid mechanics is like understanding how the invisible world of air and the visible world of water behaves, so we can build amazing things like planes, boats, cars, and even rockets. And now, you've taken your first steps to becoming a fluid mechanic.